uh, originally it looks very similar to the MS Excel software, where in Excel sheet also there is a combination of rows and columns when you open any of the worksheet of Excel, MS Excel. Uh, in case of Origin Lab, when you open this software, it opens with the two number of columns here and multiple rows. So here, okay, so as I was talking about, originally looks very similar to MS Excel, where in Excel also you have got combination of rows and columns. In case of Origin Lab also, by default it comes with a two number of columns and multiple rows. But here in Origin Lab, you can keep on adding new columns over here. So like this, there is option of add new columns like this. So in single workbook and the single workbook, you can actually store up to 94,000 number of columns worth data. It means you can store up to 94,000 number of different parameters in the single workbook and the single worksheet. And row wise, it can store up to 2 billion rows worth data. So the capacity of storing data into Origin Lab is very huge. I mean, you can store GBs of data very easily in the single workbook. And here by default it comes with a 1x column and multiple y columns. See, in case of MS Excel, there also you will be finding names like A, B, C, D, E, F, G like that. But here in case of Origin Lab, you will also get the designation. So here we have got 1x column, then multiple y columns. Now in case if I need, let's say I have got a 3-dimension data. So at any point of time, I can actually select any column. I can right click on it and set as, and I can make it as Z. For example, if I put it as Z here, then this data will become a 3-dimension data. Means I am having one X column, one Y column, another is Z column. Now, if I wish to have some error values, I can change designation from Y to Y error. So I'll be having X column, Y column, and let's say I have performed some statistical analysis like standard deviation, or if I wish to find out standard error value from the BY column, then I can create new column as a CY error, and I can plot X, Y error kind of graph. So here at any point of time, you can change designation of any column over here. So here you can fill the data in the worksheet manually. Let's say you have done some measurement or some experiment you have done, and you have got some theoretical data, so or experimental data. You can actually type those data over here. Or let's say you have collected data in various format. For example, if I go to data menu and if I click on import from file, so here Origin supports many data format which are readily available as in our library. Like for example, let's say you are having data in Excel format, like you have older Excel or newer Excel files, or if you have got notepad files or text files, or let's say you have got CSV files, or let's say you have collected data from instrument like Thermo Scientific instrument or Princeton instrument or national instrument, or let's say if I click on add remove file types, you will see lot many other data formats also. Like let's say you are having data from MATLAB or GraphPad Prism or any other software. See, we support all these data formats. So the advantage of having Origin Lab is it readily supports many data formats. So if you have data in various format, you can simply import very easily. You can import into our worksheet here using drag and drop method. And once you have a data, you wish to plot the graph. So you can go to plot menu where you will find all the graph templates. Like we have got around 190 number of inbuilt graph templates in our library. So let's say if you go to basic 2D category, you will find a scatter plot, scatter central, Y error, XY error, or column chart, stack columns, bar pie chart, 2D color pie chart, 3D color pie chart. Like this, we have got so many variety of graphs which are stored into basic 2D graph. Then we have multi-panel graphs. Like let's say you want to plot two number of Y columns against one X column. So you have got these two type of graphs. Let's say you want to plot three number of y columns against one x column, then you have got these two graph template. If you want to plot four number of y columns against one x column, then you have got these two templates. Let's say you want to plot 100 number of y columns against x, or 200,000. So this is the option. Means you can endless y columns you can actually plot against one x column using this last option. And then we have vertical panel graph, horizontal panel graph, stack columns. Means if you want to plot graph one above the another, then you can use this template. If you want to plot statistical graph like a bar chart, or you want histogram, or any statistical graph if you wish to plot, you can go to this particular category where you will find all the graph templates which are readily available in our library. If you wish to plot a contour graph like a 2D contour plot, or color field plot, or ternary plot, heat map, then you have got this. This many graph templates are there in this category. And specialized graph, like if you want to plot polar chart, windrose graph for wind energy related plots. We also have a 3D graph, like if you want to plot three-dimension data in color map format, or ternary plot. We have so many graph templates which are available here. Then we also have function plot. Function plot means you can write any mathematical equation in 2D format or 3D format. And by writing the equation itself, you can plot the graph from the equation. Once you give any values to the equation, it will simulate the equation and it will plot the graph accordingly. So those graph templates are there inside function plot. And you can also plot a graph, customized graph, and you can store it as your user defined graph. Means you can give your own name to the any of the graph, and you can store it in this folder. So by putting all this graph, we offer around 190 inbuilt graph templates in our library. And whatever graph we are plotting it here, it gives you a high DPI resolution. Means we can plot a graph up to 1200 DPI resolution. So let's say you want to put this graph in your thesis while writing a thesis, or if you want to do some paper publication. So whatever graph you plot in Origin Lab, it comes with a high DPI resolution. So you can avoid all the rejection of the plotted graph. Or no one will ask you to replot the graph again because the quality is bad or something like that. Even in poster also you can plot this graph, which comes very beautifully with high DPI resolution. So that's the main usage of Origin Lab, to get a high DPI resolution of graphs. And whatever graph you are plotting, you can actually export into any published quality format, whether it is a PDF or image format, or EPS format, or any other published quality format, which actually I will show you later on. Then we have various menus which is used for customizing your worksheet, your data, to play with your data. We have various options, out of which most important option is analysis. Means once you have a data, once you plot the graph, you also wish to do some data analysis on your data, on the imported data. Like you wish to do some mathematical data analysis, then we have this option of mathematics, where you can do interpolation of the data, extrapolation, 3D interpolation, differentiation, integration. So this kind of mathematical data analysis you can perform here. If you go to data manipulation, you can actually filter your data. Means let's say you don't require the entire data, you want to filter your data, you want to remove some data, like applying some filter on the rows and the column values, and you want to remove some data. So you can apply some filter by writing some conditions for the data, that I will show you how to filter the data later on. Then we have fitting of the data. This is also very important point. Means you have got curves, you have got so many peaks in your data, and you want to smooth those curves, you want to do the curve fitting. So Origin Lab offers around 300 inbuilt mathematical equations and functions, by using which you can do nonlinear curve fitting. For three-dimension data, you can do surface fitting, and you can do a peak fitting of your data, or you want to do the smoothing of the curve. Then you can also perform signal processing, like smoothing of the data, smoothing of the curve. Like you can apply fast Fourier transform, FFT, or short time Fourier transform, STFT, and convolution of the data, deconvolution of the data. So those kind of analysis you can perform inside signal processing. Now let's say you are having some data like spectroscopy data or XRD data, NMR data, and you want to do peak fitting, like you want to draw a baseline, and after that you want to perform peak fitting. You want to find out what is the height of the peak, what is the area inside the peak, how many positive and negative peaks are there, or you want to calculate what is the area inside the peak. So those kind of thing you can actually perform here inside these peaks and baseline. Here we also offer a full-fledged statistical data analysis module. Like if you want to do descriptive statistics, like you want to find what is the mean value, standard deviation, standard error values, or you want to calculate whether your data is normally distributed or not. So those kind of descriptive statistics you can perform here. We also offer statistics like hypothesis testing, like t-test. Like if you want to compare two sample of the data and you want to find out which sample is better. So those kind of comparative study you can do inside this hypothesis testing. Then we have ANOVA, analysis of variance. We have up to three-way ANOVA you can perform here. Then we have non-parametric tests and survival analysis, multivariate analysis, like if you want to do principal component analysis, PCA analysis kind of thing, cluster analysis. So those kind of analysis you can perform here inside multivariate analysis. Power and sample size. So this is also one type of statistical analysis you can perform here. ROC curve. We also have stat advisor, means you will be I think you might have come across some statistical tool like SPSS or Minitab kind of software. So whatever they are offering, the same thing we are offering as a one module. And Origin Lab has one got feature that it gives you a stat advice. Means here whenever you do a statistical analysis, it is very important to apply appropriate statistical algorithm on your data. So just to find out which statistical algorithm or method is appropriate data is a very difficult job. So here we have got module called Stat Advisor, where once you import a data and when you click on this particular link, it will ask you several questions related to your data. So once you answer those questions, Origin Lab itself will suggest you that which statistical method you should apply on your data to get the result out of it, to get a meaningful statistical analysis out of it. So this is the option we have given in Origin Lab. We can also do some kind of image processing. Like let's say you are having some images and you want to convert image to a data, or you want to apply some filters on it, like you want to do age detection of from the image, or you want to remove the noise from the image, or you want to apply some filter on it, or if you have data you want to convert them to image, or let's say you are having some graph in image format and you want to extract actual data out of it from the image of the graph. So such kind of image processing you can perform here in this module. Then we also have tools like uh, we have linked with LabVIEW. LabVIEW is a data acquisition software, and we can also import real-time data in our worksheet. Let's say Origin can be interfaced with any of your instrument or hardware or some system which generates real-time data. We can import real-time data to our worksheet, and we can plot dynamic moving graphs. So that is possible, and we also have inbuilt code builder. Let's say you are having knowledge on programming languages like C language, C++, or Visual Basic, Visual C, Visual C++, Python scripting. So basically, you can write your own codes and you can develop your own analysis module, or you can develop your own system which actually can generate data, or it can plot some good automatic, some new kind of graphs. It can do various kind of data analysis of your choice. So basically, you can develop your own analysis module, data analysis module. You can develop your own dialog boxes by writing equations. By writing program using this X function code. Then we also have connectivity with MATLAB. We have a MATLAB command from window within Origin Lab. It means if you have installed Origin Lab and MATLAB in the same PC, then you can open MATLAB command prompt window within Origin Lab to call any MATLAB program in Origin. Let's say you want to import some data from MATLAB to Origin, or you want to call some simulation from MATLAB to Origin Lab. So that is possible by writing commands in Origin itself using MATLAB console. Then we also have R console. That is basically RSoft is a IBM software, which is it's a statistical software. So you can also, I mean, do the programming using R console. Then we also have Python console to write Python scripting, and then we have a link with Mathematica. So this is about the menu, introduction to menu. We have various library icons here also. Then we also have some I think, yeah, it should be visible now. Yeah. So in addition to inbuilt this menu, we also have additional apps. See here, whenever you do installation of Origin Lab, you will also get this the box called apps. So basically Origin offers 350 number of additional applications. So nowadays in mobile also we are having so many apps which can be used for various purposes. Here in Origin Lab, we offer some scientific apps. So each app actually is dedicated to some kind of data analysis, which are not available inbuilt in this module, but it can be downloaded additionally. So this can be downloaded at free of cost, and it is listed on Origin website as well, which you can download, and you can use it for your data analysis purpose. For example, let's say you want to send all your data, all your plots to MS Word or MS PowerPoint. You want to prepare video presentation out of it, or you want to do some what 3D windrows, or see whatever. I mean, see, for various area of interest, we have got so many different type of apps available here. So you can give a try each of these apps for and research purpose. So this is about introduction to Origin Lab. So now I will show you how to, write a data manually, or how to import data, what kind of graphs you can plot, how to publish those graphs, then what kind of, I will also show you some of the data analysis using Origin Lab, and then you can also give a try with that. So let me begin with importing a data. See, we have some sample data in our sample folder. So whenever you install Origin Lab, normally it gets installed into program files, Origin Lab, and let's say Origin version will be there. And in this, I can go to samples folder. So here in samples, we have already given some of the readily available examples. Like let's say you want to study some image processing analysis, for example. So you can go to this folder where you will find some project files related to image processing. Now let's say if you wish to study statistics, you can go to statistics folder where we have got so many data files and project files which are available related to statistics. So like this, the category wise, we have arranged all these project files and data sheets. So first I wish to go to this import and export, and I want to import some data from here. See, here in Origin Lab, I can import data very easily. I can simply open Origin software just parallel to this folder. I can drag the data from the folder like this, and I can simply come to Origin Lab and drop it here. Like this. If I wish to import multiple data files, I can actually drag it from the folder and I can drop it here to worksheet like this. So here I have used drag and drop method to import data. Now here, if I just say tile vertically, so I can see I have imported total 3 number of data sheets like this. So I can actually go to data, import file, and I can use this option called import file, multiple ASCII. So this is the manual way to import. And here I've shown you using drag and drop method, you can import a data. So if I just see what is my actual data look like, I can just right click over here and I can open using a notepad file. So this is the additional information about my data, which are known as header lines. And here the parameter name is there, like time, temperature, magnetic field, and position, like that. And these are all unit names I've got. So now, if you see this is my source data. Okay, this is my source data. The entire data is my source data. Now here you can see these two data got separated using tab and space. So if I go to Origin Lab, when I have imported data, so Origin Lab has automatically identify how the two data got separated with each other, whether it is a space or tab or comma or dot, semicolon, colon, whatever it is. So Origin Lab will automatically identify those delimiters, and it will create those many number of columns automatically. Now here in my actual data, in my source data, there were total 4 number of columns. So one is X, another Y, CY, and DY. So Origin Lab has automatically created that many number of columns. So the time value has come inside time column, temperature value has come inside temperature column, magnetic field values have come inside this magnetic field column, position values have come inside this position column, and all the additional information, like the parameter name, it has come inside the long name row. Unit names have come inside this units row. Comments have come inside this comments row, and it has also drawn this kind of spark lines. So spark line is nothing but it's a data visualization for the stored data in the particular column. Now if I just double click on this graph, this spark line, I can see a graph of parameter name, that is a temperature versus row numbers. So basically from this particular graph I can see that as number of experimental points are going high, means as the number of row numbers are increasing, the parameter name is, which is temperature, it is exponentially declining. Means as the number of rows are increasing, my temperature is exponentially coming down. So for each column it will draw this kind of spark line. So if I have got lakhs of number of data, it is very difficult to find out how my data is behaving as number of row points are increasing. So from the spark line, I can easily come to know. So this is the feature of spark line, what Origin has come up with. Now here, if I see my data, I have got one is a time column, which is X, and remaining are the Y columns. It means all these three parameters are changing with the time. So if I want to plot a graph of all the three parameters against X, so I'm selecting all the three data, and I'll just go to plot, and here I'll go to multi panel and axis, and here I'm going to select three number of Y columns, because I have got three Y columns and one X column. So if I select this particular template, so I can see a graph of a time versus temperature, which is this one, then time versus magnetic field, and time versus position. So time versus temperature, time versus magnetic field, and time versus position. So all the three parameters are plotted against one x-axis. So if I wish to plot a graph of all the temperature values from three different columns against x, that is also possible. Means I want to plot x versus y, then x versus this y, and x versus this y. So first of all, I'm selecting this by column, and then I'm plotting it as a line graph like this. Then I will go to next workbook. I'm selecting this temperature column. I can simply drag this column from this particular workbook, and I can drop it to my graph. It will plot the graph like this. I'll go to third workbook. I'll select this by column. Then I will drag this data column from this workbook. I'll come to graph and drop it here like this. So you can use a drag and drop technique to plot a graph from various workbooks also. Not only temperature, you can also plot the CY. Let's say I want to plot a magnetic field in the same graph. So I can now open graph 2 here, and I can also just plot this data column like this. I can drop it here. Like this. So you can use a drag and drop technique to plot multiple columns from the different workbooks, and you can plot in the same graph sheet. So that is also possible. Now, let's say I have, instead of Y column, I'm keeping it as Z. I'm changing the designation. I'm making it as a 3-dimension data now. I've got one X, one Y, and Z. Now I want to plot 3-dimension graph. So I'm selecting only Z column here. I'll go to plot, and I'll go to 3D, and let me select 3D color map surface. And this will become a 3-dimension graph. So here I can click over here, and this will be a 3-dimension plot, which is created from 3-dimension data. So it's a 3D plot. Then let's say if I convert this column into error value. So this will become XY error. So I'll go to plot, and let me select basically, and let's say I'll select XY error, or maybe I can select this line as well. Okay, I'll select line here like this. Okay, if I do zoom in over here, so this so here you have got X value, this is Y value. The line, horizontal line, what you are seeing, it is a Y value, and this vertical lines, what you are seeing, is a error value. That is a CYY error. That is a error values. So this is XYY error plot. Now, if I select, I'll make it as Y again. And let's say if I want to plot a stack column, for example, so I can go to basic 2D here, or maybe multi-panel axis, and then make it as a stack graph. Okay, and this will be a stack plot. Now here, if I go to gadgets, and here I will select vertical cursor. So here, as soon as I select vertical cursor, actually I can study all the 3 values parallelly. Means I can see the temperature value, magnetic field value, and position value. So if I move this cursor, I can see that both X and Y value from all the 3 different graphs. Now let's say I want to give the labeling also. Let's say I want to give this as a label. I want to give some tag here like this. Let's see if I want to give some tag value here like this. And let's see if I want to give some values, tag values here. So when you export this graph into any published quality format, whether you want to export this graph to Word or PowerPoint or PDF or image, this value will also go along with the graph. Let's say you want to you want to export this value as well along with the graph, so that you can do it using this option, vertical cursor. So like this, we have got so many different type of graph templates, different type of graphs. We are not limited to only this many options. We also have so many apps related to graph plotting also. So many other variety of graphs are also there in these apps. So now let's say these graphs and all are ready for publication. Or if you want to write some equation, for example, let's say I want to write some equation here. So I can right click here, I can click on equation. See, Origin Lab has got linked with math type also. So here I have installed one math type software. It's a mathematical equation editor. It is also very useful. For research purpose. Let's say you want to write any equation, because as soon as you install math type, this interface, it will come in MS Word, MS Excel, MS PowerPoint, as well as in Origin Lab. So this software has got so many inbuilt symbols, mathematical symbols, and so many inbuilt equations also. So you can use all these library symbols and various format and all. You can use it for writing equation. Now let's say I want to send this particular equation on origin graph. So I'm just you can type it, or you can just send this equation on the graph like this. So this equation is appeared on my graph like this. Okay. Or I can also keep it as like this or wherever you want. Now, see here, I can go to file, and I can go to export graphs. I can open dialog box. Okay, so I'm keeping this. This is actually export graph dialog box. So I'm just take it here, auto preview. Okay, here you can export this graph into various published quality format. Means you can export to any image format like .bitmap or JPEG format or EPS format. AutoCAD is there. Then Photoshop is there. PDF format is there. So many formats are available. Let's say I'll select the standard JPEG format. And here you can export only single graph, that is active page you can export, or if you want to export all in active folder or all in active project file. So you can select various these options. If you select all in project means, let's say you have plot 100 number of graphs, so all the 100 graphs it will get export into image format at the same time. Then we also have themes. See, sometimes some journal will accept your paper if you have plotted graph in black on paper or black and white, or some specific format should be there. Each journal has got their own format. So based on their format, you can actually give this theme on the graph. Let's say I have plotted color graph. If I select black and white, means my graph will become black and white. But let's say if I have plotted line graph, then it is very difficult to differentiate between two set of data because line is same. So in that time, Origin Lab will change the style of each of the data plotted. Means one will be dash dot line, one will be dash line, dotted line, only scatter plot. So like that, the themes will be changed. So we have got so many inbuilt themes, graph themes are there. Then the most important point is this one, margin control. See, sometimes some journal will not accept your graph if you have got additional space around the scale like this. So if you select tighten page, so Origin Lab will remove unnecessary white space around the scale. Okay, so it will go from axis name. Let's say this is y axis name. Here it is ending. So from this point up to x axis. So all unnecessary white space it will be removed. It will do the cropping of image and it will export your graph in Titan page. Then you can also fix the size of the graph. This is inches, centimeter, pixel. So many. I mean. You can actually change the size of the image using this option. Then DPI resolution, the lowest is 72 and highest is 1200. So with the high DPI resolution, you can actually export your graph into image format. See, sometimes what happens is when you increase the DPI resolution, it will also increase the size of the image. So let's say you want to put it into your Word file or you want to send it to your friend through email, then the size of the image will be more. It will be very difficult to send. So that time we have also given the compression. Means you can actually minimize the size of the image by compressing the image by keeping the DPI resolution intact. Without modifying the DPI resolution, you can actually reduce the size of the image of the graph. So that is this compression is used for that purpose. So these are all different type of settings you will find inside export graph. So once you apply and click OK, this graph will export into image format with the 300 dpi resolution, or if you change it to 600, then the quality will be good like that. Okay, So this is about exporting your graph. You can also change the scale. See here, if you click on scale here like this, so this is a horizontal scale, that is bottom scale. So this horizontal scale is from -1 to 10. If you want to change, you can change it here. This is vertical scale. And this is a type of data. Means, let's say you have got log, if you have logarithmic scale, you can change it to log 2, log 10, then various type of scales are here. This is about tick labels. So these are tick labels, what you are seeing, the major tick labels and minor tick labels. So if you want to change the display, so here at present it is a decimal display. If you want to change it to scientific, like 10 to the power 1, 10 to the power 2, 3, like that, you can use this. If you want in engineering scale, you can use this. Like this, various options are there. If you want to break the graph, then this is the tab. If you want to draw a vertical and horizontal grid lines, this is the option. So this is about a scaling, what you will find inside this option. Okay, so if you want to type any text, then text tool is also there. This is for zoom in, scaling inside the graph. This is zoom out. If you want to read the data, then this is the data reader. Okay, the bottom you can see here, it will read the data. Then this is about a data reader, data cursor. Okay, various options are there. Then we have data highlighter also. Then text tool is there. Data annotation is also there. Let's say if I want to highlight this peak value, so I can simply double click over here. Then what is the peak value at this point? So 5.19 is the X value and 201.2 is the peak value, like this. So this is about data annotation. If you want to draw arrow on the graphs, so there are various tools are here. So various options are there. And now let's say you have plotted some graph, for example. Let's say I have plotted this graph here as let's say line graph, and here I want to insert some graph here like this. So let's say I have this small graph I have got, and here I wish to plot some other data. Let's say I want to plot this magnetic field value. So I can simply just drag this data and put it into this small graph like this. Okay. So you can insert a graph here, empty graph. You can also insert with a plotted graph like that. So various options are there. Then you can also plot multi-axis graph. Means, let's say, for example, I have got this XY and I'll change this designation to X again. So X1, Y1, X2, Y2. So I'm just plotting this as a one graph here. Let's say I'm plotting it as a line graph like this. Now I also want to plot X2, Y2. So I'll add one more X-axis on the top, one more Y-axis over here. Then I can simply select this column, let's say X2, Y2 like this. And I'll simply drag this to column like this. So this will plot X1, Y1 and X2, Y2. So like this, I can also plot the combination of XY plot, like X1, Y1, X2, Y2, X3, Y3 in the same graph. So these are various options available here, which you can give a try. So this is about just plotting graphs. There are various, we have so many beautiful graphs here. Even I can also show you some real-time data plotting. Let's see if I have got some files here. No. Then okay, so Zoom. Okay, so here I have got some data which can be plotted real time. So let me open this. Okay, so here I have got this 3-dimension data. Okay, see here I have plotted this 3D data in scatter manner. Now here I have got these two button, compute and create movie. So here I have created this compute button where I wish to fill the data with the, I mean, wherever there is a missing value, it should fill the data. It should do the interpolation. So here, if I click on compute here, so here you can see the data are changing. So this is dynamically the data are changing and the graph is getting simulated. You can see the graph is moving here. So this can be the case of real-time data where I'm importing data from some resource real-time in my worksheet, and I can actually plot dynamic moving graphs. And whatever this simulation is happening in my graph, I can actually create movie out of it. I can create a video out of it for my presentation purpose. So this is one way. I mean, you can represent offline data as well as online data also through Origin Lab. And you can also create a movie or video and you can actually use it for your presentation purpose. Okay, so let me show you some data analysis also. So I'll just put it as a new project file. Okay, I will show you some data analysis like curve fitting. So let me just show you some curve fitting analysis. I'll go to program files. I'll go to curve fitting folder and let me pick up some data from here. Okay. Okay, so here I'm just importing this data called outlier here. Okay, then I'm plotting this as a scatter graph. Okay, now I want to fit this data using straight line equation. So I'll go to analysis, then fitting, then I'll go to linear fit analysis, open dialog box. Okay, now here I'm converting this recalculate option as auto. And here I'm also selecting this find x from y and find y from x. So basically this will do one linear fitting analysis where it will fit this graph using straight line equation. So if I see this will create a summary report with all the result graph and statistical result and all this, I mean, the summary of the linear fitting analysis. Now, if I just go to my graph here, and here, if I see the result, which is, see here, I have fitted this data using a straight line equation called y is equal to a plus b into x. Okay, now here, whenever you do a fitting, you will see this option called adjacent R square. So this adjacent R square should be at least 0.9 and above.
મારી પાછળ પાછળ આવતા તેના ચક્કરમાં મેં ભાગી મને થોડું પેન થયા કરતું છે.
Sir, Kunal sir.
Hello, yes sir, yes sir.
Yes sir. Yes sir, yes sir. Okay. Please sir. I thought of somebody I have muted.
Okay, okay. So see here, adjacent R square has to be 0.9 and above. So here it is 0.6. That is because there are so many points are far from this line. See, whenever it does a global fitting. So it has also taken this point into count. So this point. So we have to hide all this data point so that we can improve this R square. So here there is a option of mask. See, let's see if I this option, and I'm selecting this data point like this, and the mask option has gone over. Yeah, see here, let's see if I hide this particular data point. So you can see this adjacent R square is improved. Now let's see if I hide this particular data point. So this is improved to 0.96. Okay, so basically I'm not taking these 2 points into count, and I'm doing a global fitting again. So that's why this adjacent R square is improved. So I don't want to show this bad data in my graph. So I can just go to mask and I can just say hide. So this is my final graph with the final fitting with the good adjacent R square value. So this is ready for publication. So this is about linear fitting. Let me show you non-linear also. Let's see if you have got some non-linear data. So if I have some non-linear data, I'll import. Okay, I'm importing this exponential decay data here like this. Okay, I'm plotting this as a line graph. Okay, now here there is a non-linearity in the data. Now I want to do a fitting using non-linear curve fitting. So I'll go to non-linear curve fitting option, open dialog box. So here Origin offers many inbuilt equations for doing curve fitting. So here, if you go to Origin basic function, you will find so many equations which are listed here. Let's say if I select this exponential decay one, okay, I'm selecting this equation, then what is the equation look like? So this is the formula. So this is the formula for this equation. This is a sample curve. So if you see the sample curve, it is actually matching the trend of my data. So if I go to my data here, you can see as soon as I've selected the equation, one curve has been already defined before performing curve fitting, the red color curve. Now this actually curve is matching with my data, the trend of my data. I'm happy with this particular equation. So let's say if I this is the code, these are the parameters, means Origin Lab will give some values to all these parameters. So basically, what are the parameters I have? I have got y, I have got a1, then t1, then y0. So these are all I mean x, y is a dependent, x is independent. Like this, I have got parameters. So all the parameters are defined here. You can see y0, a1, and t1. Now Origin Lab has already given these values to these parameters. Okay. So if I click on fit until converge, I'm performing a fitting. So if I click on this fit until converge, you can see the fitting has been taken place. The curve has already fitted now, and these values are also changed. Okay, these are the error values. So here, if I see the message, it says this equation has run total 8 times on the curve, and it has got this R square value as a 0.98. So this R square value has to be above 0.9 and nearer to 1. So this means this equation is matching with my data. It is appropriate for my data to doing curve fitting. So now let's say here, if I go to some other equation, see here I have got exponential decay 2 also. So for exponential decay 2, the formula is different, the curve is also different. Now if I use this equation to do fitting, so this equation has run total 7 times on my graph, on my data, but the R square is 0.99. It is excellent. It is compared to, I mean, the previous one, it has given me 0.99. So this is much better than the previous one. So like this, I can try different equations on my data to do a curve fitting. So this is again 0.9974. The formula is different. The sample curve is also different. So like this, you can try different equations on your data, and based on this R square value, you can find out which equation works better on your data. Here we have so many equations, so many variety of equations are there. We are not limited to inbuilt equations. You can write your own equation also. There is option of user defined here. You can write your own equation as well. So if I go to new, and here you can write your own equation, like expression, equations. So you can use your own expression or equation to do a fitting. So here I have got some inbuilt equation also. Let's say if I'll just cancel it. Yeah, okay. So I have got some user defined equations. I've already created the one. For example, this one, like this. Or right. So okay. So here this is the simple equations I have written. So I'm just copying this. I'll just go to these settings again, and let's see if I do this new. Okay, so I'm writing is my own equation, for example, and okay, let's say this is the equation, my own equation, and I have got this y0, a and b are the parameters. So here I'll just define a comma b comma y0 are the 3 parameters. Then here x is the independent, y is the dependent variable, and here let's say if I know the value of a, that is, let's say if it is 80, say b is -5, and let's say this is as a 90. So if I put all these 3 values, in this equation, and I'll click it finish here. Okay, and here my equation has already defined like this. As soon as I have selected my equation, you can see one line has been already defined. Now I'm going to use this my own equation to do a fitting. Okay, so here if I do fit until converge, so it has used my own equation to do a fitting, and this is the result. It is 0.98. So this is a user defined equation I have used to do a fitting. It was not available inbuilt on Origin Lab. I have written mine. So I click it OK here, and it will again create a summary report with the graph and all. Now here in analysis, I can also compare two fitted result. See, there is an option of compare models. Means I can compare my own fitted model as well as Origin Labs equation fitted model. So I can find out which equation is better. I mean, which equation gives me a better curve fitting result, whether in my own equation or Origin Labs inbuilt equation. So like this, I can compare two model at a time. I can also compare data set, rank models. Let's see if I have done the fitting using 10 different equations. So Origin Lab will do the ranking of model, means which equation is better. It comes as a rank 1, rank 2, rank 3, like that. It will decline. So this is about curve fitting and various options. Signal processing is again used for smoothing of the curve. If you want to do some FFT, fast foreign transform, or wavelet convolution of the data, deconvolution, means if you want to make your smooth data is noisy data, you can use this convolution deconvolution. If you want to smooth the noisy data, then so these are the different options you can use inside signal processing. Pick and baseline. We have this peak analyzer module. So peak analyzer is basically used for performing peak fitting of the data. So I'll take one small example related to peak fitting also. So let's say if I go to spectroscopy, and say if I use this. Okay, so if I just and here, if I go to gadgets, see in gadgets also, let's say I want to quickly find out the peak values. Okay, so let's say how many peaks are there in my graph. I want to find out. I can use this peak method. Means it will quickly find out how many peaks are there in the graph. And you can use gadgets for doing peak fit also. Let's say if I want to do peak fitting for this bigger peak. So let's say I want to study, for example, this particular peak. Okay, so this is not the one. So I'll do the peak fitting using, let's say if I use ghost, for example. Okay, so here I want to do fitting for this particular peak. You can see the peak has been already fitted, and here it will find out what is the offset value, what is the center value of this peak, what is the width of the peak from this point to this point, what is the area inside the peak, what is the height of the peak. So those kind of things it will calculate. This for negative peak. Let's see if I want to find out what is the area of this particular peak, what is the width of the peak, center of the peak. So those kind of the peak characteristic I can study from this particular feature. And if I go to analysis, and then if I go to peak and baseline and peak analyzer, open dialog box. And here I want to do a fitting of the peaks, fit peaks. Okay, so once I click on next here, so first option is it should draw baseline. So, so I'm going to use a user-defined baseline. The next step, it will draw one baseline, passing through all the points. Then the next option is I want to find out how many peaks are there. So it will find out the peak values over here. There are total 4 number of major peaks. And then in the next step, I'll go to fit control. Okay, and here I'm going to select Gaussian as the equation. There are so many peak fitting equations. So let's say if I'm selecting Gaussian here, this is the formula, this is the sample curve. And now I'm going to do a peak fitting. So I will say fit until converge. So peak fitting is done for all the peaks. I'll click it OK. And then I'll click on finish. So the peak fitting has been done here. So if I go to my result graph, so here there are total 4 number of peaks. This the equation I have used, Gaussian, and this the area inside the peak. These are the 4 areas inside the 4 peaks. This is the area in percentage, then center gravity, maximum height. So many things are here. So this particular module is being used to find out peak values. So what is the center value of the peak, height of the peak, what is the area? So those kind of calculation it will do. This is about peak fitting. Then I'll show some image processing also. Okay. So I'll go to image processing. Let's say I'm importing this car image. I can use drag and drop technique to import image also into Origin Lab. Now let's say I want to convert this image to a data. I can go to image and then convert this image to a data. Okay, so this is the data, and again from this data I can actually convert this to image as well. I can also plot 3-dimensional graph. I can go to plot menu. I can actually plot a 3-dimensional graph from this image. So this is a 3D graph. So this is a 3D graph from the 2D image. So this basically it shows this its Z dimension value shows intensity of the image. So X, Y, and the third one is the intensity of the image. So this is just a basic I have showed you. Even we have this. Okay, now here I have got blood cell image. Let's say I've got this blood cell image and I have got this 2 blood cell in background also. Now let's say I wish to first merge these 2 images into one, and then I want to remove this background image from this main image. So how can I do this? Then I'll just go to geometric transform and I'll just say offset here. First of all, just to merge these 2 images. Now, let's say this is a image 1 and the reference image is this one. Okay, and then I'm let's see if I move this image like this, for example. Okay, sorry, this offset. So let's see if I use this so much offset. Okay, so and this is offset Y. Okay, let's say these 2 images are merged and this is a result image for now. So I don't need this image, so I'll just hide this. I'll tile vertically. Now let's say if I go to image and let me do arithmetic transform, simple math. So let's say this is image 1, then second image is this one I'll take. And let's say if I'm going to use image 2 minus, sorry, image 1 minus image 2, and this is a result image. Now let me do a inversion of this. So let's say if I yeah, I'll invert this image. Okay, so this is an inverted image. And now let's say if I yeah, if I want to remove this background, I can just go to conversion, and let's see if I do a threshold, and let me so I'm just increasing the upper bound value in such a way that the background is gone now. So I'll just click it like this. And now here, let's see if I want to do edge detection. Let's say I'm keeping this as pre-width, horizontal and vertical. Okay, and let's say if I increase the threshold value, let's say I've done the edge detection like this. Okay, so from this image, this was the actual image, I have removed the background, and then I have done the edge detection. So this kind of some small, I mean, it is not full-fledged image processing module, but this kind of image processing you can perform here. And we also have this digitized image module where basically you can actually import image of the graph and you can extract actual data out of it using this digitized image. So this is a small image processing example I have showcased here. I'll show you one statistics also, just to cover most of the feature for today's session. So just let me import this data here like this. Okay, just to give a brief introduction about statistics. See here, I have got very simple example. See, one doctor is trying two different medicine on the patient. So medicine A is one medicine, another is medicine B. And doctor is reviewing what is the hourly effect of this medicine on the patient. So by doing that, he has collected these two sample data, medicine A, medicine B. Now, if I want to statistically compare these two data, these two samples, I only have to go to statistics and hypothesis testing, and I'm going to apply two sample t-test. Basically, to compare two set of data, I can use this t-test. So first set of data is medicine A, second set of data is medicine B, and then I'm going to keep the test mean as 0, mean 1 minus mean 2 greater equal 0. Significance level is 0.05. Confidence intervals are 90, 95, and 99. And I wish to see histogram, box chart, everything. Now I have done all the settings here. Just to compare these two set of data, I'll click it OK. Now here, Origin Lab will do entire statistical analysis. It will compare two set of data and it will give this summary. This blue color lines is the result line. So here it says at 0.05 significance level, when equal variance is assumed, mean 1 minus mean 2 is not significantly different from 0. The second line says that at 0.05 significance level, when equal variance is not assumed, mean 1 minus mean 2 is not significantly different from 0. So in either of these two cases, if my data is normally distributed or not normally distributed, in either of these two cases, both the medicine have affected the same way on the patient. Means the effect of the medicine is same on the patient. There is not much difference. So if this is the histogram, this is the box chart or the graphs. So we can do some a complex statistical analysis also. We have various options available here. So like this, we have various options. Now we have a video builder to prepare video from the graph. Then if you want to send all your graph to PowerPoint, this is the option. Then if you want to send your graphs to Word, we have various apps available here. For example, you can that app is not here. So in addition to all this inbuilt module, we have these apps. So that also you can give a try. So with this, actually, I'll just wind up this session. So here I have not showcased on the entire, what Origin can do, because it's a very big software. But I have tried to showcase some of the, the useful features, what you can give a try. You may contact me on this email ID. I'm just typing it here. Yeah, so you can note down this email ID, kunal@kunartech.com, or this is my phone number also. So if you have any query, please feel free to contact me. And please feel free to ask me if you have any queries today, any questions.